Hello and welcome to the unboxing video for the MediaTek Genio 350 EVK. I will show the contents of this kit, explain the setup process, and perform some live demonstrations showcasing the capabilities of the board. Then I will list some sources of information and documentation for further development. The MediaTek Genio 350 kit features the MT8365 application processor from MediaTek, which targets artificial intelligence Internet of Things applications that require audio and image processing, video display, data storage, and high-speed communications. This application processor includes 4 ARM Cortex-A53 processor cores, GPU support, internal image sensing processing, USB, and Ethernet. The kit has OS support for Android, Yocto, and Ubuntu. All this comes with low power consumption to address portable applications. First, we will review the items included on the Genio 350 EVK main motherboard. Here you can see some video interfaces, including an HDMI port, camera inputs, and touch panel input. Audio interfaces include line out and earphone outputs, as well as multiple digital and analog microphone inputs. The board supports serial communications through a number of USB and UART ports. Ethernet is also supported, as well as an external Wi-Fi module, which is included in the kit. Here we see the MT8365 applications processor and related memory. The application is loaded into eMMC, and there is LPDDR4 for use during runtime. An SD card slot is also available. The board also includes the MediaTek power management device and other interfaces to support the development and debugging process. Along with the motherboard, here are the additional components contained in the kit. In addition to these components, you must also supply your own USB cables and development PC. A quick start guide for the Genio 350 EVK is located on the MediaTek GitLab page, with instructions on hardware setup and PC tools installation to enable building, flashing, and interacting with the example software. After unpacking, insert the wireless module and camera boards. Insert the SAS cables. Connect the LCM and touch panel ribbon cables, and then secure the connection by pushing down on the connector lever actuator. Connect the USB cables to UART 0 and USB 0, and connect the power cable. Software developers may want to run Linux on their PC to develop their own software. However, MediaTek has saved us considerable time by providing a pre-built image which runs on a Windows platform. This image includes a tested Yocto build with necessary device drivers for connectivity and video, and it includes some test applications that will help us evaluate the performance and devices on this board. We're now ready to download the pre-built image based on a Yocto distribution from the MediaTek GitLab page and flash it into the non-volatile flash memory of the kit. Open a Windows command prompt and enter the commands shown in the Quick Start Guide. Then reboot the board into flash download mode by holding the volume up button while pressing the reset button. The flashing process is performed through the USB 0 connection on the kit, which also displays progress via the command prompt window. When connected to UART 0 via your terminal program, you can monitor the debug log messages and then log in once the kit is fully booted. Follow the instructions in the Quick Start Guide to run the camera demo, which displays 2 real-time images captured from the camera sensors. Here you see one video stream of what I am seeing and a second video stream of the camera that is facing me. The EVK supports OpenGLES applications. The first displays a rotating cube and is a simple GLES program demonstrating how to drive bare metal graphics without a Wayland compositor. The second OpenGLES demo draws a rotating triangle on a transparent Wayland window. The Quick Start Guide allows you to demonstrate a few features of the kit in just minutes. However, there are many possibilities, such as voice and vision processing for facial, gesture, and motion recognition, as well as speed recognition, sound isolation, biotech, and biometric measurements. Reference the MediaTek GitLab page for more information, including detailed technical documentation, additional features, support for writing your own software, and helpful tips, including a section with frequently asked questions.